All right, welcome to one for absolute values. So absolute value is a measurement of distance. We don't typically talk about going in negative distance. When we start doing some different directional things, and when you get into physics, we'll do some negative distance figures where we usually use south and west as negative. But it's not like I would say, well, I went negative 40 miles to get to liberal. No, I would say 40 miles. So that's an absolute value where we're kind of measuring a distance, and we don't measure that in negative numbers. So we can go ahead and plug in some numbers here. If it tells me that x equals -2, just plug that in for x. Now, what tends to trip people up is they say, but you're inside absolute value bars. You can't put a negative number inside of there. You totally can. You just can't. When I drop the bars, that's when I'm going to drop the negative. Let it be negative in there for as long as those bars are there, okay? All right, so now simplify inside the bars. When we talked about our gems, G stood for groupings. Absolute value bars is one of those groupings. Fix in there first, okay? So 4 times -2 is -8. And -8 plus 3 is -5. And if I drop the bars, that's when I finally get to drop the negative. So now it's just a +5. And +5 minus 3.5 is 1.5. Also known as, let me get a better equal sign going here, 1.5, also known as 3/2. Okay, so it would be the same thing on 1B where you would keep that negative plugged in until the very end. Hey, and you'll notice I write my absolute value bars really big. It's really easy for this to look like a 12 and this to look like 11. A couple ways that you can make that stand out is to make them really tall like I do, or do them in a different color, or maybe even highlight them. That way you know not to mistake that for a number. All right, so we can go ahead and solve these as well. What you have to remember is that when you dropped the bars, dropped the negative, this could have been a positive or a negative number. I don't know if that actually equaled a +9 or -9, because when I dropped the bars, I dropped the negative. So to account for that, you're going to have to write 2 different equations. So the first one is going to be this exact thing, but lose the negative, or lose the absolute value bars. So 9 equals x plus 12. You're going to do that again, but notice that I am going to change something this time. You see what I changed? Make the answer negative. Okay, so then you can solve like normal. And that's -3 equals x. Like so. Hey, before you circle those as your final answers, do yourself a favor. Take those back in and plug them into the original equation. -3 plus 12 is 9. And if you drop the bars, drop the negative, 9 equals 9. Okay? This is an answer. It's good to go. Try this one. -21 plus 12 is -9. Extra tall absolute value bars here. Drop the bars, drop the -9 equals 9. So this is another good answer. I can go ahead and circle it. The reason I want you to check is because sometimes it's not going to work out. So let's try 4A. Here's a hint to you. When you are solving these, get the absolute value bars by themselves first. So I'm going to add x to absolute value bar x plus 1 equals 4x minus 4. Divide by 2. Okay, so now what I'm going to do when I write my 2 different equations, the first one is going to be x plus 1 equals 2x minus 2. The other one what you have to understand is you're making the entire right side negative. So that's going to end up flipping the signs of everything on the right side, like so. All right, now solve. So I'm going to subtract x. Oh, what about, well, I'm sorry guys. I keep getting distracted. That should have been a 1 here. Okay, now let's do this one. Okay, I divided by 3 without showing my work very well there. Take these back in and test them. See what we get. If I have 2 absolute value bar, 3 plus 1 minus 3, does that equal 3 times 3 minus 4? So 3 plus 1 is 4. Drop the bars, drop the negative, that's still just going to be 4. And 2 times 4 is 8. And 8 minus 3 is 5. 3 times 3 is 9. 9 minus 4 is 5. Since 5 does equal 5, this is an answer. It works. Gotta squeeze this other one in here. So what is it? 2 absolute value bar 1/3 plus 1 minus 1/3 equals 3 times 1/3 minus 4. So I have, this is going to be 1 and 1/3. Drop the bars, drop the negative. And this is now going to be 2 and 2/3, or now 2 and 1/3. This is going to be 3 minus 4, negative 1. That's not true. 2 and 1/3 does not equal negative 1, so this is not an answer. Okay, that's why it's important to plug it back in. Verify that it will work. I want to come back to 3a here and check this one out. Like I said, I want you to get the absolute value bars by themselves first. So what I'm going to do is divide by negative 2. So that I have the absolute value of 3a equaling negative 3. So my first equation is 3a equals negative 3. And my second one is 3a equals, wait a minute, I said the second time you should make it negative. It's already negative. What I need you to do is stop for a minute and think. What kind of number are you always going to have on the left at that step right there? When you drop the bars, drop the negative, you will always get a positive number. So what you're telling me is that I'm going to have a positive number, no matter what it is, a positive number, and it's going to equal a negative 3. A positive number is going to equal a negative number. When in the world is that ever going to be possible? The answer is never. This is no solution.